Hi, I'm Giulio.
Hi, I'm Rayhan.
Hi, I'm Enrico. We're introducing the project we worked on last semester for our computer architecture course. It's a blackjack game running on an FPGA board called Zybo. Our tool of choice was Vivado, a VHDL programming suite.
Our board features an FPGA chip alongside with an ARM processor, which we didn't use, and which is powered by the micro USB port, also used for programming. As far as video is concerned, we use the VGA output also on board.
At its current state, the game supports only one player and just the basic features of Blackjack. However, we're planning to make a multiplayer mode and a specific variation of the card games such as Double Down, Insurance, and so on.
Each of us was in charge of a specific part of the project. Ryan took care of the algorithm, Julie designed the graphics, and I, Enrico, designed the I/O. So initially the idea was to use a PS2 keyboard, but however, due to lack of time and resources, we resorted to using the built-in buttons on the board and switches, and since we're implementing a simplified version of Blackjack, those were enough. So there are two models that I implemented. Hardware reset, that is this one, that basically takes one button, debounces it, and then outputs two control signals, be upper and be lower, that serve a purpose later on in the stage, and Brian will discuss those. Then we have I/O block, that is the main I/O block, as the name suggests, that takes switches and buttons, debounces them, and then outputs several control signals that are I/O bus and I/O choice, and LEDs. And we use the switches and the LEDs to output the betting amount in the betting stage, difficulty setting in the difficulty setting stage, and in all other states we have the current state output in 4 bits by means of the LEDs.
Hi, I'm Rayhan again. I took care of the algorithm used in this game. A finite state machine is created within the framework of the single control unit module, which serves as the brain of this whole game. The game works in this way. At the start of the game, the user decides to bet a certain amount of money. A signal is then sent from the control unit to the wallet module to check the availability of the entered amount of money. If the player owns the set amount of money, the wallet module sends back a signal to the central control unit, allowing the game to go on. When the user or the computer decide to hit, that is, to take a card, the control unit outputs a signal to the memory block, which then randomly picks a card from the deck. If the card was not picked before, this memory signals the control unit to proceed, informing it about the availability of the card. When the user or the computer decide to stand, that is, stop taking the cards, the control unit simply moves on to the next state. The basic rules are these. The score can't exceed 21. After receiving 4 cards each, whoever has the highest score wins. If the player runs out of money, bankruptcy occurs, and the game ends. If this state is never reached, the user can continue to play indefinitely.
Me, Giulio, took care of the video part. As previously stated, we choose to employ the VGA output. Accordingly to the VGA specification, I built a Zynq unit, which was able to synchronize each specific pixel on the screen at each clock signal. An appropriate frequency for the clock has been chosen in relation to the screen resolution. Additionally, several units constructing the images for each phase in the game were implemented. Information about the phase and other data to be shown are sent by the CPU and stored in a buffer to properly stabilize the signal before they are transmitted to the assigned unit. All these units are then connected to a multiplexer, which is able, knowing the state of the game, to connect with the external port the signal incoming from the right block. Then the output is sent out by means of a 16-bit signals defining colors through the RGB spectrum. And finally, you can see everything on the screen.
This is an example of how the game works. So first you get this splash screen, and then this button brings you to the first difficulty selection screen. So by setting these switches, you can set the difficulty. In this case, I want this one, which is medium, as you can see in the top left corner. And then you have to bet. So you set the switches in binary according to the amount you want to bet, and is a bet 15, so I bet 15 as it's displayed here, and my updated budget right here. Then I have to take a card, so I press this button right here and I get a card. So my total stays at 8. I want another card, so I press the button again and I get 14, and also the dealer gets his card, so I hit again and I get 20, and now I am at a reasonable amount, so I want to stand, that is not take any more cards, so I press this button. I'm at 20 and I won. And then I'm brought back to the betting stage, at which I can set the betting amount, that is pressing this button again and getting new cards and new budget.
So as a conclusion, we'd like to thank Professor Sterpone and Professor Montuschi for the encouragement during the first stages of development, and Politecnico di Torino for providing all the hardware and facilities. So like, share and subscribe and all that good stuff, and see you next time.
Bye.